All right, in this problem, we are trying to find the acceleration of the propeller and the linear speed of the propeller. Now, first thing we're going to do, like with all kinematics problems, is we're going to try and take all the numbers that we have in this problem, we're going to write them down. So I read through the problem and I say, okay, I know it accelerates from rest. That means that my initial angular speed is going to be 0. Next, I know that it gets to a speed of 200 radians per second, so that's how fast it's going to eventually go. So that's my final angular speed. The next thing is I know that it's going to reach that speed in 2.5 seconds, so that's my time. And it's asking me to find that angular acceleration. And it's actually asking me to find the linear speed as well, and it tells me that the radius is 1.5 meters. So we'll find the first thing it asks for first, which is that angular acceleration. We're going to use our rotational kinematics equations for this. So we are going to use the equation that does not have theta in it, because that's the one variable we don't have and don't care about. So that would be omega f equals omega naught plus alpha t. I'm going to rearrange for alpha, and I'd get omega f minus omega naught divided by t equals alpha. Plugging in our numbers, we get 200 radians per second minus 0 radians per second all over that 2.5 seconds gives us our alpha, and when we plug that into our calculator, we should get 80 radians per second squared for our angular acceleration. So that's our first answer. And then finishing up, it's asking for, hey, what is the linear speed of a point at the end of that propeller? I'll change colors just for fun. And we know that converting from angular to linear, or from linear to angular, is going to just be this one equation for speed, and that's going to be that the angular speed equals velocity divided by the radius. We're trying to find the velocity, so we'll multiply the angular speed times that radius. So what's my final angular speed of my propeller? That's going to be 200 radians per second. And my radius is 1.5 meters. So when I plug that into my calculator, I should get that a point at the end of the propeller has a speed, a linear speed, of 300 meters per second, which is pretty darn fast.